In this video, section 4.3, ratios and proportions. To begin, let's take a pair of numbers. I'm going to take 30 and 10. Now, the ratio of these numbers is their quotient. That is to say, the ratio is 30 divided by 10. Let's take another pair, 15 and 5. The ratio of these numbers is 15 divided by 5. Finally, let's take one last pair, 24 and 4. The ratio of these numbers is 24 divided by 4. Okay, so you might be sitting there thinking, well, we can reduce these guys. That is correct. This ratio, 30 to 10, would reduce down to 3 to 1. Likewise, 15 to 5 would reduce to 3 to 1. 24 to 4, however, would reduce down to 6, not 4, 6 to 1. And notice how I'm saying 3 to 1, etc. It's a very common way to say a ratio. One of the other ways that you could write a ratio would be 3:1, and this would be, say, 6:1. But if we're going to do any solving, having these guys in fractional form is fantastic. Now, that circle was a little incorrect. One of those things doesn't belong. Which one? 6 to 1. Why? Well, these two are equal. When we reduce them down and they're equal like that, we could say, right, 30 divided by 10 is equal to 15 divided by 5. So 30 to 10 is the same as 5 to 5. They're both 3 to 1. When that happens, we would call these two guys a proportion. That's where the proportion comes in. It's a proportion when two ratios are equal, or we say that two ratios are equal. What do I mean when we say two ratios are equal? Well, suppose we have something like this. X divided by 8 is equal to 3 divided by 4. These guys are proportionate, but we don't know what value goes up there. Well, we know how to solve this. This is way back in the inversing multiplication section, section 3.2. We're just going to take both sides, multiply by 8, and that will give us our solution. These 8's will cancel. The left-hand side will just be x. 4 and 8, that simplifies to 2. So we have 3 times 2, that's 6. X is equal to 6. Here's another example. Let's take a look at this proportion. X divided by 2 is equal to 10 divided by 7. We're just going to take both sides of this equation, both sides of the proportion, multiply by 2. These cancel, and we're left with x is equal to 20 to 7, or 20/7. That's our solution. It's not a whole number. That's fine. Likewise, ratios don't need to have integers in them. A common proportion is 1.78 to 1, and I'll write it like this, or it would be 1.78 divided by 1. This happens to be the ratio when you take 1920 and divide it by 1080. What? Well, this happens to be the width in pixels of my computer monitor, and this is the height in pixels of my computer monitor. This would be the resolution of my monitor, 1.78 to 1. That's the aspect ratio. This is a fairly widescreen aspect ratio. And there's some others listed in the book. It's common when you're talking about visual media. Okay, let's take a look at another type of problem we can solve. In the problems we've been solving, x, the value that we were looking for, has been a numerator. What if we have something like this, where x is in the denominator? What if this was just some number? We could multiply and undo it. And remember, a solution always has the form x is equal to, or variable is equal to. So this is what we want. So we need to get this guy out of the denominator. Let's multiply by x. X represents a number, so we can go ahead and, most of the time, treat it like a number. These x's will cancel out, provided x is not 0, but since we're solving for something in the denominator, that's assumed. And our left-hand side will be 4. The right-hand side, 5 divided by 20 is equal to x. Now, we'll just go ahead and multiply both sides of this equation by the reciprocal. That's 20 divided by 5. These cancel. We're left with just x on that right-hand side, which is what we wanted. And then, you know what? 20 divided by 5 is 4. So this is just 4. 4 times 4. Hey, that's 16. That's our solution. X is equal to 16. And this form is called the rule of 3. A divided by x is equal to C divided by D implies that x is equal to AD divided by C. Again, this is the rule of 3. Theorem 4.3.4 in the textbook. Let's solve one more rule of 3 problem. We'll take 8 divided by x. We'll set that equal to 7/3. What's the first thing we're going to do? Get that x out of the denominator. And how are we going to do that? Multiply by x. Alright. We'll fill in the rest of the problem about this. These cancel out. Our left-hand side becomes 8. And we'll just leave the right-hand side as is and multiply by the reciprocal. So we'll multiply by 3/7, multiply by 3/7 on both sides, multiply by 8, fill in the rest of the equation around it. These cancel, the right-hand side becomes just x, and we'll multiply 3 by 8 and get 24 divided by 7. That's it for section 4.3. Thanks.